The broadcast is now starting. All attendees are in listen-only mode.
Good morning, good afternoon, wherever you are in the country. It's Mark from SolidCAM, here today with your 30-minute free training session, SolidCAM Live. With me, as always, is Kevin Rankle. Hey, Kevin.
Hey, how's it going?
So today, I thought we would cover another list of options that probably gets overlooked because oftentimes these lists, there's always something in there that once we learn how to use the software, we learn that one particular toolpath, we never really go back and check it out. So let's take a look at another one of these, and that is the HSS toolpath. I'm going to go to Add Milling Operation, HSS. Now in the HSS toolpath, a lot of us go up here, we choose our technology. So really what you're doing here is you're just choosing the surface you'd like to machine, and then you're choosing some sort of contour to tell it where you'd like to travel across that surface. Everyone pretty much knows that window. And if you don't, there are training videos on our YouTube channel for that. In the geometry section, this is where you choose your geometry, but this top right corner here, I find a lot of people don't really know what goes on in this window. And this could be really helpful depending on what it is you're doing. So for instance, area type really is just telling it what to do with that surface. So we did talk about, I think either yesterday or last week, the HSM toolpath and the constraint boundaries. Well, with a surface-based toolpath, the constraints are actually from the surface itself. So if you look at the bottom left corner right now, we have a blue surface that we would have selected in our geometry section, and we have a representation of the red toolpath. That red toolpath is stopping short of going right to the edges there. And that's because it's currently set to full avoid cuts at exact edges. So essentially what that's referring to is it's stopping short of the actual full diameter of the tool. You can imagine that this top portion right here, this little offset, is basically the radius of the tool. So the edges of the surface can act as a constraint boundary. That can be useful if you're trying to stay within the surface of, let's say, a flat surface like this one, or maybe trying to stay away from the edges of this one as well. But if you're not looking to use the edges of the surface as your boundary, if you want to kind of just go outside while keeping a tangency with let's say, a ball mill or a lollipop in some cases, depending on what you're doing, you want to just allow the tool to wander as much as it can around the surface to machine that. Well, that's basically this guy over here. So full avoid, full start and end at exact surface edges. Once I click on that, now you can see that the red toolpath goes right to the edges. Now, if you still wanted to pull back from those edges a bit, you'll notice that as soon as we grab that second option, we get the margins ability. We get this margins parameter. That allows us to add whatever we want to offset from those edges. But I often use this setting here because if I'm trying to avoid the edges or I'm trying to avoid the edges because I want to avoid something outside the surface, I'm going to use the gouge check. I'm going to select surfaces nearby that I do not want to machine, that I want to pull back from, and I want to use the surface that I've chosen on my drive surface to fully allow the tool to move. So basically, if I chose the drive surface, it's a surface I'm looking to completely finish or completely machine, and I don't want to have any limits, especially with HSS, because there's really nothing in here that should be constraining you other than a gouge check surface. Now that second option is giving you a little more of an ability to limit the travel of the tool in basically the Z direction. If you look at the toolpath now in the bottom left corner, it has that red toolpath, but it also has 2 points that you indicate. So let's do something real quick here. I'm going to go and do the first option so we can see how that moves on, let's say, a surface like this one.
And as you guys are maybe viewing this at a later time, too, you'll have to remember that, if we do like a constant Z, like what Mark just grabbed, your options will change for your type. So with the constant Z, we can't do limits by number of cuts and stuff like that. So it definitely depends on the technology that you choose inside of the HSS.
Yes, definitely. So the option that Kevin mentioned didn't pop up yet because, like you said, we're just doing constant Z right now. Once we get one of the other options, you'll see that there's another option that pops up in that list. But let's keep it simple for now. Let's just go with a ball mill. So we're doing constant Z on that face right there. And since this is a very simple technology, I'm just going to leave everything as simple as it is. Let's just get some really tight corners here, really tight stepovers. We'll just do a save and calculate. Okay, so a little bit of an offset from that edge there. Now, because this is constant Z, it's offset from those upper and lower edges, but that still stays within the range of the toolpath. Now, let's set this to the second option. You can see that it goes a little tighter up. So it's not actually trying to keep that entire diameter of that ball mill within the edges of the surface. It allowed it to go a little bit up there. Hopefully everybody saw that. It was pretty quick. Now, let's go to limit cuts by 1 or 2 points. I find this one very useful when you've chosen your technology, you've chosen your contours, whatever you're doing to define the toolpath, but it's just wandering a little too far in one direction or another. And the toolpath itself looks really good, except for maybe the surface is doing something crazy on the bottom there. This could be with the translated part. This could be with maybe just the technology that you've chosen. It works really well in terms of step over at a certain point. But then once we get, let's say on this one here, probably a really good example, it looks like it's pretty uniform over here. But once it gets a little more horizontal, there's such spacing there that it's not the cleanest. You know, if you can imagine that if you ever worked with HSS, sometimes there's portions that are really good, and then portions that probably the geometry is just driving it a little too specifically, and we're not liking that finish there. So let's say we want to limit the travel of the tool to just within the area that it looks good. Well, as soon as we say limit cuts by 1 or 2 points, that literally allows me to choose 2 points along the cut. So let's say maybe here. And you can see I'm just freehanding it on the surface there. Really what it's recording is the exact point in space along that toolpath. And let's say we go down to maybe it looks good over here. So I've got those 2 points. Now when I do a save and calculate, the toolpath is just traveling between those 2 points there. Now remember, we're talking about tangency as well. So I've told it pretty much somewhere around here, but that's still a tangent point of the tool. And I told it pretty much somewhere around here, but the center of the tool still has to go that far down to machine a portion over there. So we're limiting the travel of the tool to between 2 points in basically the travel of the tool, the cut direction of the tool. But you can see that with this constant Z, I'm getting the good portion of the tool path, and I'm eliminating the bit that I didn't like on the top there. So just another way to modify, in this case, a very simple version of HSS. But let's say we get something a little more complex.
And that also works great for toolpath trimming as well.
Yes.
By the points too. So if you guys want to, you know, we all know that we all have used different SolidCAM CAM packages out there, and they all have their different names. But you could also think of that as some toolpath trimming.
It is one of the ways you can do toolpath trimming, and pretty much it is one of the more basic ways as well. There is a lot of modification you can do to surfaces and that sort of thing, but some of those might not be available in the 2.5D or Express packages of SolidCAM. But definitely the by limit by 2 points is part of that basic menu. Now, what I'm doing here is I'm doing morph between boundary curves, and I'm choosing the top and the bottom curve of our little basic surface here, and that should open up an additional option of determine by number of cuts. So you've probably seen this option before in either one of our tips and tricks videos where we talked about swarf machining and 5-axis, or possibly in one of our other toolpaths where we basically just kind of show you how to do a single one pass around the part. That's essentially what that does. Determine by number of cuts. Again, if we look in the bottom left corner, the graphic usually helps us understand what that is. Instead of giving it a step over, so if we go to toolpath parameters here, I have it set to a 20th step over, but it's not actually doing that step over across the surface. Now what it's doing is it's doing as many cuts as I tell it to. So right now, if I just do save and calculate, we get that one pass down the middle there. If I set this up with, let's say, 5, now it's 5 passes across that surface. So this is another way to limit the travel of the tool, limit the amount of work the toolpath is doing. And it's actually a little more application-based. I mean, for instance, with this surface, I'm trying to finish it. I'm not going to sit here trying to figure out how many cuts it needs. I would actually just set it back to one of the first 2 options and then just tell it, this is the step over I'd like you to do the entire part with as many step overs as it needs. This one right here is a little more specific to what it is you're trying to do with the part. If you're trying to only do, let's say, maybe a slice down the middle, or like I said, with swarf machining, I would tell it to use the side of the tool and a 5-axis toolpath but not do any steps. Just go right down to the bottom of the surface and then just do one pass, maybe doing a final finishing pass or something like that. So this is just another way to further control it. But sorry,
yeah, you can also use that as pencil milling. You know, if you just want that one initial pass going all the way through, like Mark was saying, kind of like a pencil milling.
Yeah, absolutely. So this is a good way to get your HSS to act as a pencil mill toolpath outside of you know, the HSM pencil mill. Pencil milling as a term basically is, you know, just that one pass. But there are many different toolpaths that actually can do pencil mill, and that's a good example, like Kevin said. And I think that's it for that list there. Let's set this back to maybe just the second option here, and let's get a toolpath that we can take a look at here. And let me, since we're on the topic of trimming toolpaths, let's just get this guy to be a little cleaner. Okay, so we got a nice clean toolpath that's just doing that corner radius there. Now, in terms of trimming toolpaths, one of the other options you can do is, let's say we do the entire surface, we've got this technology here, but again, I'm not looking to do the entire surface. I'm probably just going to try and clean up maybe something in the center there.
And
that's what this option.
We'll propose that as Brad was machining and had a oops, and then we had to fill it full of weld to fix it. This is a great option right here.
All right, so let's close this guy down and let's go and add a sketch. I'm going to add a sketch to our part model. Put a sketch on that plane there. Let's get our top view. So let's say, like Kevin said, maybe there's a little bit of a nick there. We filled it in with some weld or something like that. Now we have to refinish it. Grab a circle, and I'll make a circle probably just as big as the part, but just maybe just that one circle shape there. All right, there we go. Exit out of there, exit out of there. Now we have a nice two-dimensional circle there. I'll go back into our toolpath. As soon as I engage the Use 2D boundary, I have the ability to project that boundary in any one of these directions, even a custom-made direction. In this case, I'll just do it in the Z direction. And I'll choose my two-dimensional boundary. That just happens to be that circle there. And again, very similar to what we saw with the HSM toolpath and the constraint boundaries, I'm going to generate an entire toolpath like we just did, but then I'm going to trim it to only exist inside of that circle. So that is being projected. Let's see if we can get this in a perpendicular view. So projected in Z. So you can see that it gets that circular kind of shape there. Not sure why the Z is coming out like that, but basically that's the point of that 2D boundary. It's to limit the travel, but only within there, but still generating something based off of the drive geometry, the drive surface, the end curve, and the end edge curve. So any questions on that?
Looking good.
Okay. Okay, so let's take that off, and we'll go into toolpath parameters, modify. So again, another way to modify your toolpath is the extend/trim. So you can check that box. And then you've got extensions or trims on either the tangential direction or the side direction. So in this case, let's say we have in the tangential direction, we'll expand it by, let's do something big like 25% of the tool diameter so we can really see it when we extend it.
Now, the nice thing with this extension is what it's basically doing is extending the surface. So if Mark was to grab, let's say on that where the saw cut would be on the side, on that radius surface right there. So if Mark was doing like that surface right there and he wanted to extend it out in like HSM, what would happen is that extension would come out and drop straight down in Z, where in HSS, it's actually continuing on the surface going out. And this really helps out with blending lines or maybe blending two different toolpaths together to have a little bit of overlap right there. So a great feature in there, and anytime you're trying to extend something out, it won't drop straight down. It will just basically do like if you were to do a surface extension on that specific face of that model.
Exactly. I usually like to show this to people that instead of filling gaps or trying to add geometry to kind of better refine their toolpath, a lot of times if you just extend a surface, you can get a cleaner toolpath, especially going back to, like, let's say it's a translated file. There have been some 5-axis parts that I've had to help customers with where it's a translated file from some other design or some other software, and if you've ever done 5-axis, you know that the geometries really drive what happens in 5-axis. And if that surface is good to a certain point, and then after a while, the geometry just goes crazy with curvature and you can't really get a clean 5-axis toolpath, sometimes you can actually just take the clean surfaces and extend them, and then you get that toolpath leading off the part. And then if it goes a little wonky off the part, you're not concerned. Or if the geometry that you have, if you just took out certain bits of the geometry and you get a clean toolpath, if it was just extended, then the same thing. You get the ability to just extend your surface kind of like you did here, and you don't even have to add new stock or new material. You can just basically say, just lead off by a little bit. This can also give you the ability to get almost intermittent lead in, lead out, because it's off the part. So if it does a direct move or anything like that when it links the slices, then sometimes that's a little cleaner than if you try to manipulate the link section to get lead in, lead out as it goes in and out of the part. So that's kind of another way to kind of just lead off the part and do whatever you need to do to reposition it. Now, that's just extension. Trim works the same way. So we can do a negative 25%. And then if we do a save and calculate, it trims back by that 25%. So same sort of thing. Let's say if there's not really any surfaces that are really that are really useful for your gouge checking or anything like that, but you knew if you just trimmed it back by, let's say, the radius of the tool or something, you get a nice clean looking tool path. So same sort of thing. Anytime you don't have the geometry on screen and you find that you have to modify it with a sketch or another surface, that's one way. Or sometimes you can find these modifiers in each of our toolpaths where it can actually do this sort of modification. And that kind of leads me into the other modification you can do, and that's round corners. Now, I don't know if I really have a good example of that on this part, but these graphics really show off what this option does. So if you look on the top image, it's a nice 90-degree sharp corner, but that tool has a certain radius that it can't fit in there. So what the toolpath will do is it'll generate this kind of triangular motion to make sure it gets all kinds of contact points in there. But rather than do that, let's say we want it to just go in and come out, make its own corner, make a nice smooth 90-degree turn, not even trying to do this triangular motion. Well, if you check the box, that's what you get. That's basically what this is telling us. Once we check that box, put my mouse in there, now we can see what this option is going to do. It actually will add a radius to those corners. So with our 1/4-inch ball mill, rather than going into this really tight corner and doing triangular motion, I can put in a radius of, let's say this was a 1/4 inch, I'll put in 125 as a minimum. That way I'll get just a sharp turn 90 degrees in and out of a corner, and it'll always leave behind that 1/8 radius. If I want to even make it a little bit of an arc in that tiny arc area, then I just expand this. So I can make this, let's say, 130. And then it'll always go into the 90-degree corners, but leaving a 130 rad. Give it just a nice little smooth arc movement, no matter what corner it's in. And this is another way of getting this sort of corner rad control without having to go to the solid and changing fillets or adding fillets or anything like that. You can get the toolpath to be a little smoother, a little easier on the machine itself, and all you got to do is just check that box and plug in that value. Hopefully that makes sense.
Now, one thing that I see happen a lot, and it happened today, is if we could maybe go over the linking again and go ahead and turn the links back to how it is by default.
Yep.
So Mark and I will often get this call of maybe there's a a toolpath issue or a question on there, but then we'll see this toolpath jumping up and down like this. Now this is fully controllable, and one thing that we kind of notice is not a lot of people know about it or just kind of forget about it. But to really eliminate that up and down movement, you guys can come into your link section. And so basically right now is on that top half, if there is a gap, meaning a hole, maybe you're trying to fill over a slot, something like that, is there. As it sits right now, it would go up to the clearance, move over, and then drop back down. So what you guys can do is for any of those large gaps, and that's all based off of the tool percentage, we can do a, my go-to is kind of the follow surface, but you can do several different options here to eliminate that retract movement there. So you're not wasting, because that's a lot of time going up and down right there. And
Yep.
you know, if you're doing one part, no big deal. But if you're doing several parts, that time definitely does add up for you guys, as well as the links between slices. And that's what Mark is showing in red right now.
Yep. So it's all dependent on the geometry, but Kevin's absolutely right. I mean, milliseconds, when you multiply them by the thousands of parts we have to make, that could be hours of production. So take a look at these edge movements here. This is linking between the slices. So each movement of the tool back and forth, because I do have it set to zigzag, as it moves back and forth, it's just repositioning up in the clearance area, and then it basically just comes back down to the same area and just does the next slice. And that is a waste of movement. Now, the reason it goes to clearance area is just for safety reasons. By default, it doesn't know that if you're trying to avoid anything nearby in terms of collisions, especially with the gap along cut, that is just a gap in the surface. That surface could be a hole, or it could be the base of some sort of boss that's coming out of that surface. So by default, the clearance area is the safety option. But let's look at the link between slices here. So every small move of the tool would be a direct move. It'll just literally go from point A to point B. But these movements here are just a little larger than, well, you can see here. So small move as size in percent of the step over. So the step over is currently set to 20 thou. And if that movement between the slices is larger than 110% of that 20 thou, which looks like it is, it thinks it has to go to the clearance area. But again, that's a waste of time. So to trim that up, like Kevin said, you've got this whole list here. And the go-to would be the clearance area, the follow surfaces. Because once you do that, you get that nice curvature following that surface there. But let's say, for instance, there's something about this where you actually need to do that clearance. You don't always have to go just between follow surfaces, direct, or clearance area. You can actually do safety distance and rapid as well. And that should just trim it just slightly. So you can see the difference there. It's actually just going to the incremental distance that we've defined as safety distance away from the part. We talked about levels yesterday. So this is just the safety distance away from the part, and you see it's incremental. So that's just safety distance away from wherever the part happens to be. And if you contrast that with the clearance area, it's a shorter distance, and it's a shorter distance incrementally as well. So it's always just the same amount. Whereas here, if I'm down here, I don't have to go all the way up here. Whereas if I'm here, it's a shorter distance, but still it's a waste of time. So clearance area, direct, or safety distance and rapid.
And my personal favorite is, instead of doing direct, I like doing the blend spline, just because with that blend spline, for the large gap, sorry, Mark, with that blend spline, you're doing an arc in between there. So instead of we're doing direct, it's doing a sharp edge. So we're moving over an X, machine stops, we're moving up in Y, machine stops, and then we're starting back in the cut, where this one actually does a nice little radius, so you don't get that jerkiness in the machine as well.
Yeah, absolutely. A little easier on the machine, gets it's easier on the servos. You know, anything that can smooth up the tool path, that's going to look a little cleaner as well.
This one really comes in handy if you're butting up against another surface. So we all know when we're changing directions in here, and we're stopping at X, you know, and we're moving up in Y, we get that little bit of a little witness mark there. And if we're trying to blend surfaces, that's where we don't want those marks to be able to see those machine surfaces. And that's kind of why it's called the blend spline, is because it's blending it through, creating that spline in there of that arc. So now if Mark had another surface that was butted up next to that, and we did the tangent or the extension overlap, as well as the blend spline, that tool path intersection point would be nearly invisible.
And that's pretty much the point of HSS. It's a finishing toolpath. You want to make sure that that finish is good. You eliminate any kind of witness lines or any kind of indication of a change of direction. Because you do, one of the recommendations, at least on my side when I train people, is you want to make sure that you break up your part into the different surfaces so that you don't get a lot of weird jerky motions, a lot of weird looking toolpaths. If you break it up into the different surfaces, you get smooth looking toolpaths where they need to be. So this one here has that nice smoothness there. And then every other toolpath, I would change direction or choose a different technology to follow the flow of the surface. So that blending between surfaces, like Kevin said, is actually really important when you're using HSS. So any questions on any of this?
I think we're looking good.
All right. So if there are any questions, comments, topics you'd like to be covered, any parts you'd like us to cover, as long as they can go on YouTube, Kevin's going to put my email in the chat area, and you can use that email to email me your parts, your questions, your topics, your comments. If you'd like to get your own personalized training, you can use that as well. So just send me an email with a day and time that you're free, and we can get into your own personalized training session using GoToMeeting, but using the phone, so you can answer your questions live over the phone. And if you know anybody that can benefit from SolidCAM, give them our contact info or get them in contact with us. And if they get into a demo, you get that $100 gift card. If it goes to sale, you get a 20% of that sale. So that could be a good chunk of money depending on what the sale is. Okay, so you see there's a question there. So you say break it up, but do you have any method of determining? The method to determine how to break it up is, at least the way I've been doing things, is I just look at the part and see which direction the surfaces are moving in. So let's say if we take a look at how I've done a lot of these examples here. Maybe not these first three. Let's go to this one here. So if I look at this little bell shape on the back here, I would stick with something like linear or perpendicular to curve like I've done here, because it's a nice flat surface. There's no need for me to really change too much direction, especially if you consider that if I did change direction, if I did maybe parallel to curve, it's going to collapse the toolpath here, and I'm not going to get a nice smooth looking toolpath. Or if we take a look at some of these options down here, this is the constant Z toolpath. That looks like it applies pretty nice to this little disc shape, but I would not really want to do it on any kind of these fillets here because the flow doesn't yield itself to constant Z. So when I say break up the surface, I'm basically just saying each surface or each collection of surfaces, see which direction the toolpath is going, and then choose your HSS technology based off that. So if you have full HSS, you have the ability to choose a curve and stay parallel to that curve, or choose a curve and be perpendicular to that curve, or in the case of these corner fillets, sometimes it's better to use morph between boundary curves, because then what you get is you get a toolpath that can follow the exact curvature and movement of that toolpath. Whereas if I tried to do that with constant Z, I would get a little bit of a fanning when it gets horizontal on the top there, or when I'm choosing something that is itself kind of fanning out, maybe like this sort of surface here. I would want something that blends the toolpath nicely across there.
And a lot of this also depends on what kind of surface finish you're trying to achieve. You know, if this, you know, usually on a part like this, you're going to have, or we'll take it as a mold, you're going to have areas that you want a better RA finish on versus other areas. So what, you know, on a part like this, we could do the entire part with 3D machining, come back with a HSM 3D constant step over. But if we have a special call out for, you know, we want a really nice finish on all the radiuses, that would be a point where you come in with the HSS to kind of finish up that detail work. And I like to, you know, HSM is like throwing a blanket over the entire part, where HSS is like the surgeon's scalpel coming in there and just fine tuning specific little areas.
Yeah, that's a good way to put it, because you notice that with the surface-based toolpath, you get that really fine detail, whereas with the, like Kevin said, with the HSM, you're basically applying one technology to the whole solid. So that's what we need those constraint boundaries for, because that also gives the ability to limit the travel of the tool and kind of break up your solid into the different technologies that you'd like to do. So like we saw the other day with the HSM boundaries, some of these toolpaths make sense to be done on certain areas, but maybe not the whole part. Or if we do something like HSM radial, that works really well on this surface here, but I had to limit the travel of the tool to only that one area, or else I'd be doing the whole thing with radial, and that doesn't make sense for the whole part. So again, look at your geometry and let that inform you as to which technology to use, either in HSM or HSS.
And one thing to really get that wow factor, if Mark was just to take, and this kind of goes back to our boundary machining, but if Mark on a flat face was to do that as a linear surface, and he did that, he kicked it off at a 45-degree angle, and then he did a sketch inside there and broke up that surface. And what you can actually do, I'm trying to show you with my finger, but it's not working. What you can do is like engrave or have your company logo on there, but do the same tool path, but do it at a different angle, and you'll really get a really kind of cool projection of that surface having your company logo on there as well. So if that's, does that make sense, Mark?
Yeah, it does. It does. But if anyone wants to see a better example of it, that could be the next SolidCAM Live. We'll give it to Kevin, and he can program something that looks good.
I can show you what I'm
and then use the fingers on his screen.
Yeah.
Yeah. Okay, so then Brad is asking about the multi-axis constant stepover, which is a new toolpath for SolidCAM for the entire part. You could do that as well. Keep in mind that multi-axis constant stepover is a 5-axis toolpath, but it is, like we've described before, it is it's a bare bones version of the 5-axis toolpath. But you could use multi-axis constant stepover for the entire part, but it's again the same sort of thing as HSM. You could use 3D constant stepover for the entire part, where the toolpath is going to be really long, it's changing a lot of directions, and it's not really following the surface, the flow of the surface, flow of the solid, but it does the job. Whereas if you really fine tune where you want the toolpath to go, you can trim your toolpath. So kind of going back to what we talked about at the beginning of the class today, trimming toolpaths, reducing cycle time by movements, and you can get probably a better finish as well. Because if we were to use multi-axis constant stepover and we would be moving in all directions, maybe even spiraling out, depending on what it analyzes from the solid, that's not going to be necessary for every one of these surfaces. I don't need a 90-degree turn on this surface here when I could just do linear and get a nice smooth toolpath that goes back and forth. So a lot of those toolpaths that will do the whole thing, that you basically just set it and forget it sort of toolpath, they get the job done. But like I would say, if you spend less time on programming, there's more time on the machine. If there's less time on the machine, it means that you spend more time programming. You put more detail into your selections, and you're controlling the lead in, lead out, or like we saw at the link section, you're really fine tuning the gap along cut sort of thing. More time on the programming side means less time, cycle time sometimes. And this could be one of those things. Multi-axis constant stepover is a great toolpath, but I would use it sparingly. I wouldn't use it just as a hammer, like Kevin said, with the blanket. I wouldn't just blanket a toolpath on here and then I'm done. Only because if you ever see that toolpath, it changes directions a lot. So it might be a waste of cycle time.
Yep.
At least that's what I would say.
Yep.
Okay, so if there are any other questions, my email is in the chat section, so you can always send me your questions, your comments, your parts, whatever you'd like to see. If you have suggestions for something for us to do tomorrow or throughout the week, we are continuing this until the end of June of this year. So you can send us the email, send us your parts. We'll definitely get to that. We'll just add it to the list of things we're going to cover. Like I said, we'll do this every day at 2 p.m. But until tomorrow, stay safe, keep your family safe, stay sane, keep busy. We will talk to you guys tomorrow.
All right. Have a good night.